welcome to the webinar R&D cooperation between universities and industry challenges and solutions. My name is Veniamin Kizeev. I'm a global head of Smarter You SIG and a board of member of the Academy of WinBD. And today I'm moderating this webinar. First of all, a few words about us and about organizer. This webinar organizer today is IPMA SIG Smarter University and IPMA SIG Energy, and also, of course, International Project Management Association. And a few words about all SIGs and whole idea. The Smarter University SIGs exist to promote project management excellence within and across universities in all spheres. We are delivering best practice, standards, and education, and providing opportunities to network. And if we speak about all SIGs, we have a few opportunities for people who like project management. You can be a speaker of events, participate in a research group, participate in the preparation of new standard of project management, and of course, be an organizer of different events, research, and other activities. If you want to be a part of us, please join us and feel free to connect about all questions for SIG IPMA Smarter U. And of course, we come back to our today agenda, and today we discuss about really hot topic for universities. And I think that we have really great speakers today for this topic. First of all, let me introduce Irina Schreiber, Global Head of IPMA SIG Energy, PhD researcher, leader, speaker, mentor, lecturer, influencer, and a lot of different other titles. Irina, thank you that you are here today. It's super nice to have you. And I want to say in the other corner, because this man not from science, but very close to science. He is from technology entrepreneurship sphere. Dmitry Strodubtsov, CTO and co-founder of Mighty Buildings, sustainability expert, and really man who create a huge company, technology company in sustainable sphere. Thank you, Dmitry, that you find time for us today. First of all, I want to give you a few minutes to introduce yourself. And it will be really great if you share a little information about your experience, about your connection with our topic today. I think that, Irina, we start with you. What do you think about this topic and how you connect with this, and what's your experience?
Yeah, hi everyone, and thanks a lot, Veniamin. I wonder if you have to fight or to collaborate. This is a great challenge for us with Dmitry right now. But actually, for more than 20 years, I'm a member of one or another an international scientific club. At the moment is European Research Organization for European Organization for Nuclear Research, known as CERN, located in Switzerland, in Geneva. And the thing is, it's laboratory for fundamental research, and from the first sight, it sounds like it has very little to do with the universities, but actually it has to do a lot to do with the universities, because out of 15,000 members, people who work at CERN, only 3,000 really work for CERN employees. Everyone else are members of different universities, so-called users at CERN. Already, Fundamental Research Lab collaborates with different universities to create different projects. And as we work for the gigantic, the biggest, the most energetic machine, the art of energy technology and development in high energy physics, we do need to collaborate with industry to create this innovative and new technology to run this machine. So this is constant collaboration between us and researchers, I would call it that way, not really academia, if you want, and industry. And I face it for more than 20 years, and I can see how it's advantages for both sides and how challenging it is as well for both sides, for us and for industry as well.
Okay, super. You answered for my next question, to be honest, about do we really need it, cooperation between university and industry? But thank you, Dmitry. A few words about you.
Yeah, sure. I would say that first of all, I'm entrepreneur, and I would say like multiple times I did different companies in my life in different industries, starting with consumer electronic hardware. It was booming market and it was booming industry in 2014 and 15. And so we did a very cool product called Creopulp. It was a 3D printing pen. Very nice. And the reason why I'm talking about it is that it was a combination actually of unique market case, which was a completely new market, by the way, So it was like a second company, a very new market niche, which was like initiated and kicked off at that time. And we actually managed to brought the new materials, new advanced materials, I would say, composite materials, and managed to pack the product in a way that it brings a new customer experience with a very beautiful design, which was a very important combination of different things in order to achieve market success. So you always have to combine different things. And all my life I was trying to figure out how to bring new technologies into the market and how to pack this product in a way that it would solve the market problem and market issue and the customer's issues. So going in the later stages of my life, actually, I switched to more like an industrial automation kind of business, and we started a company called Mighty Buildings, which I'm running right now. So the company actually grew up in 5 years from the very scratch, from the idea actually, and in 5 years we managed to create it and develop from the scratch the very new material, a new composite material, which actually the only one containing polymers, which is applicable for the real real walls of the houses. And it is also a very unique and very interesting story where we managed to combine not only the hardcore innovations in material science and also we managed to combine a lot of knowledge and experience in certification. In order to be able to deliver this product to the market, you have to unlock a lot of very tricky problems, actually very tricky blockers, which all the construction companies are facing with when introducing new materials. And we successfully managed to actually unlock all of those barriers basically, and introduce not only the new material but mostly the final product, which is the house. And as a company, we designed ourselves in a way to deliver the final turnkey product for the end customer. And this is especially something what I'm trying to the reason why I'm trying to uncover this thing is to address my personal concern about how hard it is to transfer and to commercialize technologies from the universities and from the academia to the market. And it happened that actually in early years of my career, I was working in the technology transfer area in the some of the universities, and we was managed to collaborate in a very, very well performing way with some of the top universities, and was trying to figure out how to hack the technology transfer center faster compared to others, how to commercialize technologies. And it was really hard. And actually, that was probably the reason why I decided to start my own company, is that I just, I was blocked actually with some of the unrealized potential actually in the in investments, which was unavailable in the market at that time. So I would say, that the as a summary, right, as I'm trying to summarize, I see that there is a lot of potential. First of all, I see that there is a lot of potential in the academia science, and it is really the place where all the innovations are like initiated and growing up. And second thing is that I see a lot of a significant gap, I would say, in between like academia science and the business. And that was one of the reasons why actually at some point of my life I started thinking about how to approach this problem in a more effective way, and even thought about decentralized science as a way to approach this problem. So yeah, actually, let me stop here, because I can tell about it like a lot, and let's better to switch to better facilitating on this thing.
Yeah, but it's super interesting, to be honest, your experience, especially I take for me the idea that it's really easier to start your own company than to decide some troubles with transfer technology. It's a big surprise for me. Yes, Irina.
But this is what I want right now, because what we are facing very often, that we face an opposite problem, not like transfer our thing to industry, but just the request. Industry doesn't want to come to us. I'm talking about projects on a global level, because what happens with fundamental science, with research inside of the universities, we are long-term projects very often. Yeah, and it's quite common for universities in different fields of science, doesn't matter, chemistry, biology, physics. Universities approaching and searching for long-term projects. Well, for industry, you need the result here and now and commercialize. And I always thought that the bigger problem comes from the other end, that industry doesn't want it very much. But what I hear now from Dmitry, that the problem comes as well from this side, that you cannot really transfer this knowledge. Even if you want to do that, it's easier to start your own business, to grab it or to take it or develop it inside of your own R&D department, business unit, but not to connect to the university. This is a bit surprising outcome for me.
Yeah. Okay, friends. Here I want to say that, dear participants, you also have opportunity to ask question. For this, you have the Q&A section. You can send message. I use this question in our discussion. Please feel free to do this. And Irina, the next question for you. But in this idea from different perspective, should scientists think about the interest of the industry, or do they have other goals, completely other goals? What are they?
What was the first, chicken or an egg, right?
Yeah.
Who should be more important? Okay, I will start from a successful project, okay? First of all, because I'm more familiar with that. Again, I'm coming back to CERN, and I will explain a bit later why. You cannot choose, really, right? What about CERN, about facility of CERN? It's a huge facility which requires a lot of tools which scientists, but on their own, cannot develop. Let's say we develop a new scientific project, and this is what happened actually with the Large Hadron Collider. We had to develop a huge scientific project. We have tons of data, yeah? We need to set up collaboration with, I don't know, it was Cisco, I believe, Oracle, different collaborations of this kind, which was set up between CERN and companies, IBM as well, right? Because we wanted to handle our data. Then other things was like cryogenic. We needed the innovative, really the latest technology, cryogenic things, which companies were developing for us, but which later were taken back to company, to industrial things, right? To use them for some aerospace or electronic company, different kind of things like this. Then radiation protection thing. If you can imagine, this is nuclear research lab, and then we need good shielding, good radiation protection. And then we need radiation resistant electronics, which can lead to development. We order it from companies. We know what we need. We ask companies, and companies take our research and our results as well to themselves. Let's say nuclear power plants, it can be used there. I'm just using simple examples which are connecting one and another. So it's profitable for both sides. But when we are talking about that, it's a huge project funded by how many? 23 permanent members and 8 or 9 associated members. So 32 or 33 countries which are putting their money, taxpayers' money, to fund this huge lab, which doesn't happen normally between universities. If we take a single university and industrial company, it's more difficult to create a project like this. So successful collaboration of many universities inside of CERN brought to results like this. And if we take a look on the independent universities like University of Oxford, University of Cambridge, as far as I know, they both were collaborating with some medical companies. Don't ask me the name, but Novaris or something like this. Yeah, this is I think was a collaboration between them for MRI scanning, CT scanning, because again, the universities taking it from research inside of big labs like this, or they are working on that inside of huge collaboration research facilities. Then they develop it further in the universities, and then they take it further to industry. It does exist, but it creates a lot of problems on the way, especially when it's one-to-one. Yeah, when you have only a small collaboration or a small lab inside of the university. Usually industrial projects, they require a lot of fundings, yeah, which for their research, especially long-term research, university don't get. The way funding comes to the companies and funding comes to the universities is quite different thing, right? And this creates different goals, creates a huge problem. Then I wouldn't even go now into the problem like intellectual property. Again, if we're talking about huge collaboration, open open source information, and research which is done inside of CERN is open to everyone, is free for everyone. When you talk about one independent university, who gets the rights for intellectual property, for example? This can become
university or researcher. Can be both sides, yeah.
Yeah, I mean, I'm not talking that it's not solvable, but it's definitely creates a lot of tension. But it is, again, we are in our modern world, especially when we talk about that artificial intelligence can replace us in many cases. So the way to collaborate and big organization, big labs, not only in high energy physics, but in any different fields, big collaboration like this between universities, which requires collaboration with industries. It's an amazing solution. It's an exemplary model solution for this case. Again, requires a lot of effort and a lot of funding, but it does exist.
Okay, yeah, I heard about different goals, different funding in the tools, and so on and so on. It's a reason why we have so big gap. And if we back to Dmitry, I want to ask you, you have a lot of experience in creating technology startups. It's obvious, but do you somehow attract universities in this process? Yes or no? And if no or yes, why?
Yeah. Actually, it's a really good question, and I would say we never actually attracted any IP from the universities while doing our core innovations, mostly in-house. The reason was that first, it was really hard in most of the times, to better approach the IP rights and make sure that, especially when you're doing the venture-backed company, it is usually hard to explain to investor how you would protect the IP. Because it's in most of the times it is a gray area, right? Even when you have licensing agreement, so it is always hard to explain, and makes a lot of questions actually from the investors. So what would be in this case and that case? So what would, if you would like scale your company fast and etc. So the final rights still owned by university, right? And it is really challenging, especially for startups. I believe that in corporate world, this is what I heard actually from a lot of my friends and other co-founders from other companies, etc. Who worked in corporations. In corporation world, it is actually different. The rules of the game are a little bit more clear and transparent, but still, it is hard. And what I know, from some of the facts which are in my head right now, on top of my head, the only 3%, as far as I know, 3% of the entire science funding finally got commercialized, basically. I mean, got returns from revenues actually to the in licensing fees, to coming back to universities, which is really just a few percentage, right, from the entire funding. And the example which were covered just recently, mostly about the basic science, right? And the basic science is a very different animal, right? And it is definitely something which is the most critical and the most important for the humanity. The cold fusion, which I believe CERN is focusing on, right, is really something everyone are expecting to have in the nearest future. In my personal opinions, it would be 10 to 15 years, not earlier, but probably 50 years, depending on depending on the forecast. But and coming back to your question, I never asked by myself, why. First, I think it is an IP an IP issues, and second, I would say the answer is that we just probably one of the reasons is that we were more flexible in terms of how we work with IP when you do it in-house, etc. And you probably in case if we would have a chance to collaborate with more teams inside the universities and inside of academia in a more flexible way, when we would have a chance to choose multiple a set of different IPs, right? When you're building a product, it is always hard to figure out what the exact IP you will need at the end, because it all starts from the customer development. You figure out the product requirements, etc. When it goes from the market, right? When it goes from the technology, it's more clear. When you have something to commercialize, and this is exactly the way how most of the universities are thinking about the commercialization, right? When they have some certain technology and they think how they can match this with something, with some of the products to bring them so-called unfair advantage, right? Basically, unlocking more, market volume or new market verticals, or, unlocking more collaboration with other companies, etc. But, still coming back to the cradle, actually, when you start thinking about the building a product, it all starts with a real customer's pain, right? And only when you figure out those pains, so you can think about the technology stack which would stay behind of your product, right? And in most of the cases, just simply more predictable when you do all the development by your own. And we have this actually when working with IP. So we have this like square which divided on 4 parts, actually, which IP would be, would make sense to work and start like licensing at the moment, which is in most of the cases not the core IP of the company. And everything which is core, usually the mindset of those companies is to build in-house, because the company, especially if it goes to the venture capital, right, and the interests of the larger, spectrum of investors, etc. In some cases, most of them are very well-known individuals, etc. Like in Mighty Buildings, for example, like top 5 venture capital funds are sitting in the board of the company, and it is really important for most of them, to have the core rights, core IP developed internally. And then later on, when you get to the certain level, when you get to the certain stage of the company development, and you're actually unlocking probably like new markets, when the technology is proven, right? When you scaled it up to certain technology readiness level, TRL, right? And you're ready to scale, you're ready to partner, etc. So you might open up more, windows actually, and more, collaborative environment, right? To build more relationship, etc., by leveraging like the external IP. But in case when you start, the company, especially in deep tech, in most of the cases, and I have like specific, even like I have a statistics here. So because I've been talking with a bunch of the venture capital funds, and it is, the companies who are starting with IP owned by some of the academia structures, like universities, etc., is like in between like 5 to 7% only, which is, mostly because of the all these, issues happening, and risks, potential, I would say even like risks which might happen, but still don't happen. Yeah.
Super, thank you. I like our discussion because we watch from different positions, from technology entrepreneurship frontier and venture capital, from scientific frontier, and so on and so on. It's super cool. But Irina, we have a lot of new challenges in our world, energy challenges, climate challenges, and so on and so on. And can global challenges, for example, in the field of climate, become a driver for cooperation between universities and industry more and more? Because it looks that it's really important task for both sides, and we need each other, university, scientists, plus industry, and so on.
No,
does it work?
Absolutely. Actually, I was trying to remember the name. There is a small company, startup, for small module nuclear reactors, which actually was founded by people who worked at CERN before. And this is actually what happens as well. And I think Dmitry by himself, if I looked through your CV briefly, a good example of that, like we are not talking only about real product, but people itself, talents, right, which we are grabbing into startups of different companies or R&D's units of different companies. But okay, talking about global challenges, of course, I mean, what Dmitry briefly mentioned, fusion. Actually, CERN is fission. It's a different process, but fusion is very related to that. And when we are talking about energy crisis and climate problems in our world, even fundamental labs, CERN, they do think about that. I should not say it out loud, but this is a picture which was given at CERN openly. 1 ton of CO2 emission. What was that? It was 4,000 kilometers car drive, I think. For how long do you think our accelerator have to work to have 1 ton of CO2 emission? CO2. Huh? Just try to guess. How long should it run? A day, 2, a year?
Great question.
To produce 1 ton.
The accelerator, which is part of the CERN facility, right?
Mhm.
I see. The particles accelerator, right?
Particle accelerator, because it requires a lot of energy. This is the most.
An hour.
Some numbers, it's around one sort of whole Switzerland energy consumption. Okay, per year. So try to guess how long we need to run our accelerator to create 1 ton of CO2.
Probably 1 second. I don't know,
not 1 second, but 2.5 minutes. It's pretty close. I mean, in this scale. Yeah. So meaning that we have to take care of that a lot. We have to think about what we do in this development, in this area as well. So there is a lot of things which done inside of universities and inside of big scientific lab, inside of academia, to think about this problem, because we cannot stay away from that. And this is how we developed different tools, how we can manage that at CERN. Besides of education and, switching off heating for 10 days, there is a collaboration. One of the projects which I know, collaboration with the heating, left from operation can be used to heat up buildings which are on the top, because the accelerator itself 100 meters underground, and we can heat up buildings which are absolutely on top. I live basically on top of the ring, so it's underneath, under my house. One of the projects like this, we do install green energy, like solar panels, not wind energy, of course, but solar panels on our buildings, in our facilities. We have so-called green buildings. We try to contribute with that to that, and we help as well with development of all this stuff. And as I said, I just look, it's called Nucleo. Clear name that they're working on nuclear reactors. People who worked at CERN for many years, and they are now creating a company, energy company, to work on small modular reactors. So if you want, this happens inside of academia, but it happens as well as a talent source or talent development inside of academia, which are coming to industries and bring their knowledge with them as well.
Yeah, super example, really super example. And I know that Dmitry also has some big concern in the climate problem and sustainable problem, and we need more project. And Dmitry, I know that you had a big idea to involve more researchers in big challenges, and it's really great task. Can you say a few words about this idea? What challenges you found, or maybe the best practice, which is really a good example and work?
Yeah, sure. I spent 5 years working in the construction area, in construction industry, which actually I came there without real background, and I never worked in construction. I never even built my own house, and I actually had zero knowledge about the construction, and that was the reason actually why I came, why me and my co-founder came to construction. And it was really, funny when we started visiting some of our customers' homes and sites, looking for the real places for building our homes. And we had only some of the samples of our material in our bag, and that's it. So basically we just, you know, get into their houses, you know, show what we have. And people are so curious about, okay, what might be the house? So what might it look like? So what's the design, and what's the energy efficiency, and what's this and that, etc. And we realized a lot of customers' pains actually while working with the real customers. And since we none of us had the proper background, so we didn't know actually what we shouldn't do. I mean, and we kind of reimagine and redesign the product from the scratch without even knowing actually how it should be made, basically how it should be designed. And that's probably one of the reasons actually why it was so, I mean, initial business model of the company was direct to consumer. So we basically sold our houses like Tesla cars, you know, without any retailers, you know, realtors or some other like intermediary, right? So we just sold it directly to customers. And in B2C model, it was so, you know, so popular, I would say, our designs and etc. And you know, the interesting is that when we start thinking and start diving into the industry more, so we've realized how broken it is. And we, as a company, and me as an engineer, actually start thinking about the industry in a way how we can approach and increase productivity, basically, how we can unlock more productivity in the industry, because you know it's so inefficient in terms of the way how the house is produced these days. And as an engineer, I start thinking about like, okay, why don't we like leverage more automation here and there, right? And you know, unlock more productivity and like produce more square foot of the houses, like on like square foot of the factory. So the whole idea was around building the houses inside the factories, actually micro factories. And when we almost like solve this problem, we realized that it's not enough. You know, and the second piece, which you know we realized, was that it's not enough, you know, to build houses efficiently in terms of productivity, right? But the other, which is even more important topic, so we have to build those houses in a more sustainable way, you know. And no one at the market wants to have cheaper houses. Actually, right now, people want to have like more sustainable houses, which is quite like quite logical, right? And so the challenge was how to build materials in our technology stack in order to fight this climate change more effectively compared to any other company. And we actually invented a lot of, you know, innovations around it, and not only in materials, but also like in design, the way how we design buildings, you know. And first of all, like unlocking more dematerialization, basically by like eliminating a lot of materials, just simply, right, eliminating steel, you know, all these like higher CO2 contributors from the construction process at all. Right, and the material we've invented initially is actually a structural material, you know, and unfortunately we was not able to introduce it as a structural material from the scratch because of too much regulated industry, and we started as a you know, as non-construction material, as not structural material, but it's still actually in our roadmap for the couple of next years. You know, but the problem we faced was that construction is contributing like, I mean, including all the production processes around the construction and supply chain and delivery, etc. So if we like count everything, it will contribute like 25% of global CO2 emissions, right? Which is really huge. And so the challenge was how to, you know, unlock more, you know, decarbonization technologies to the industry in order to accelerate this decarbonization process faster, because the industry is so broken in multiple directions actually, and those two I've actually just demonstrated right now, right? are so much different. And if like someone focusing on automation, that it doesn't mean that it's going to be focusing on sustainability, right? And most of the corporations are just simply don't know actually what to do. And we realize that, there are, given that there are significant climate targets right now, like on CO2 reduction globally, right? Because of this Paris agreement, etc. So the large companies and large corporations already introduce those targets into their roadmaps and start pushing their downstream supply chain and downstream like suppliers, right? Which are usually contributing like 80%, which we call like tier 3, right? And who are usually contributing 80% of all these CO2 emissions. And this part is really hard to achieve. And we start figuring out that a lot of those demand on innovations are happening from the small and medium enterprise companies who simply don't know what to do. And I'm just trying to explain. Actually, I'll still answer a question. I'm just trying to explain that there is a lot of demand actually on the climate tech, which is not unfilled, because the reason is very simple, and it's very I would say stupid. The reason is that just it is not enough scientists, like climatic and decarbonization scientists in the area. That's it. And I mean, if you will, I could tell more about more other reasons, right? But and the process of introducing those new decarbonization technologies is really hard and long, right? You have to go through all this TRL stages, figure out all these hot spots of what exactly you need to deliver, right? Because it doesn't mean that all of us, all of the scientists, just need to start, bringing something to the market, right? There are very certain gaps, what we call gaps, right, in climate tech, which have to be unlocked by the certain research. But the problem is, even if we would bring more scientists into the climate tech, right, into the decarbonization, so it still doesn't mean that all this innovation will be successful in terms of a real contribution to the global, to the humanity, right, and to the planet, right. And the next stage, when you motivate and you incentivize enough, you figure out the gaps, you incentivize enough scientists around it, right. Motivate them to switch from where they are right now to decarbonization or to climate tech, right. So then the next stage is to define the rule of the game when all of those scientists would be highly motivated to contribute it, and not only from the social aspects, but actually from their personal motivation, right, to get a little bit more money. I mean, to finally, be, somehow, what do you call it, motivated, right, from the outcome, right, from
keep the sparkle in their eyes, right?
Yeah.
It's not always money. Yeah, I mean, agree that.
And we usually forget about it. Okay, science, it is so nice, and we all will do something nice, and that's really cool. But okay, what about money? What about motivation of real people? They are putting their lives, trying to achieve this certain sometimes very hard goals, right? And we need to incentivize those people. And I start thinking, okay, so how it's done right now? And actually, I've seen so much inefficiencies, and I would say distractions at the process of how the IP created and how it is licensed. And yeah, I came up with the probably it's my one of the ideas I will still be working in the next 10 years. The idea of decentralized science, which is not my idea definitely, but it is the right time at the market right now, to start thinking about it by leveraging more potential actually from those scientists, motivating them better to switch to the climate tech, to work on the very certain problems of the corporations, right, which are impacting the most part of the CO2 emissions, and finally give them the way how to be motivated is the outcome, right? And the blockchain and all this Web3 stack is really applicable for for this particular purpose, and it's just probably not the right time still. And what I've realized is that licensing the technologies is still hard, right? But by leveraging more, I would say by highlighting more hotspots from the corporations in terms of climate tech, would motivate and incentivize those people around, right, and the companies in the area to think about those solutions. How to motivate better those people. Yeah, that's probably was the long answer, but yeah. Sorry.
No, I think that it's really great that you explain step by step all your story from the start of this idea and how it develops and what's the problem. I really like this vision because I want to be in the better world in some places which will be more beautiful, and I hope that we save our planet for our children. And in this perspective, your vision is super great and super productive. Yeah.
Can I just? I was just, when I was listening to Dmitry, I was thinking it certainly doesn't hurt to bring more scientists, but maybe it wouldn't hurt to get rid of some politicians inside of the process, because I think this is a huge problem which we have, especially what Dmitry was talking about. How do we licensing and how do we put regulation on all of that? And being the global head of SIG Energy and looking constantly on all this stuff, how it's happening. The question, do we want green or clean, is always on my mind, because we're definitely now politically approaching for the green world, which doesn't mean clean at all. And this is where science should be plus and minus political discussions on that, because a lot of problems comes not from deficit of understanding how to proceed technologically, but actually from the way which was chosen by the people who don't understand at all how it works. So they have some political idea, but they don't have understanding technological or financial or whatever, economical, how it works and how it should proceed. And this is really our biggest problem at the moment.
Yeah, it's true. It's also one of perspective, and it's a big question if we speak about third party like political or something else. Okay, Irina, but pragmatic question. What mistakes does the industry make when interacting with scientists?
One of that, Dmitry already mentioned, you cannot be this. I always say to my students, when I give public lectures, when I give scientific lectures, you shouldn't do science if you can live without that. So the main characteristic of a good scientist is this sparkle in his eyes when he likes this science. So you cannot motivate with money enough. What was the limit? I don't know. A couple of years ago in the United States, it was $100,000 per year per household. Maybe now it's a little bit high, but it's not very high thing. Yeah. So definitely the mistakes usually is that industry expects the results here now, and they have their own goals. And I do understand it, but we need to find the right combination of a common goal, what we want to approach, which would keep, and here I absolutely agree with Dmitry, motivation is the key. We have to keep motivation from both sides. Again, I mean, everyone says good words about the place where he exists. There are, I find it, because I find it an amazing example. I was counting right now, there are 33 startups currently at CERN. And as far as I know, I only have data back to a couple of years ago, but as far as I know, at CERN, the survival of these startups is much higher than in general. So it's as well a close connection to some fundamental research where you base it on the real technology which proved itself scientifically in some space. helps these startups to survive, I believe. But again, yeah, when we come to questions, communication is the key, and IPs and all of that. We need to establish clear communication. How do we share that? How can we find a common funding? Because funding problem, again, for commercial companies as well, it's a problem, right? How do you find money? But sometimes you can profit from universities, from scientific labs, which get grants from government and get their research. But you have to find, what do you bring back? This is what very often industrial companies forget about. What do we bring back? We're here, we want you to give us this result, and we're ready to pay you for this result. It doesn't work this way with scientists. They are not people who are thinking about only financial advantages. They're people who are ready to proceed when it's an interesting topic for them. So you have to combine this motivation, interest, with motivation, financial motivation as well. Absolutely agree on that. So there are many little things, but this one I find the most important from my opinion.
Super. Thank you. And I think that my last question will be for you, boss. I want to come back to IPMA, International Project Management Association, because inside IPMA we try to collect best practices about project management. We try to create new standards and try to share these for a lot of professional like best practice and to increasing productivity and so on and so on. But in case of collaboration between university and industry and R&D project, should we create new tools, or it's mostly about new leaders or new culture? What do you think in this way, Dmitry?
Yeah, I think all of that is actually applicable. Definitely, more project leaders is definitely necessary, especially for academia. I don't know actually how exactly should we call them, right? Whether it's like project leaders or not, but someone who definitely know the market requirements and the knowledge gaps actually which are exist in the industry. Because knowledge gaps is not only in the basic science, right? They are also in the industry, and all of the industries are the very certain like number of those gaps which have to be addressed, and corporations are usually not enough, to resolve all of those bottlenecks. And the second thing is, so basically first is like people, right? I mean, the right people who would build the gap, who will build the bridge, right, between company and the business and the academia. Second thing is finding the more ways of, transferring the knowledge in a more transparent first, like, because transparency is one of the key problems of the market right now. Which is limiting the exposure of IP created in academia and transferring it to the industry. So the more transparent it is, meaning that the way how exactly you store the IP, because IP is usually information, right? So how do you store it? How do you share it? How do you control and trace the information, right? It is like super important in order to make sure that everyone are comfortable, first of all to share, then to actually leverage and to understand how the certain knowledge contributed to the certain like revenue stream, ideally, right? Which is hard, but like it doesn't mean that it's not doable. I mean, everything's doable, right? We just need to start with something, and it's definitely the problem I see. And the third thing I already mentioned is actually the incentivization. So I actually spoke with multiple scientists as well as decision makers in corporations, and I realized that for scientists specifically, one of the most significant dilemma in their lives when they thinking about whether to switch from from the academia career to industry is that they actually lose themselves as a scientist, which is really a dilemma actually for most of them, even though they will get like better terms, which in most of the cases are, and they are, getting more like career opportunities, etc. But the way how they will identify themselves is really important for scientists. And what they've realized is that it's definitely not a way to unlock more technologies and resolve more bottlenecks when all the scientists will just bring to academia, to industry, right? So academia will always stay as the core actually to create all the innovations for all the industries, right? Especially in the basic level, you're starting from basic level and the research and development level, etc. But we just need to think about the ways how we motivate those scientists keep staying in academia while contributing like their knowledge into the industry.
Yeah, thank you, Dmitry. Irina, do you want to add something in this point?
No, I think it's just perfect, and Dmitry, he can see it from the other side, because this is exactly that. I mean, many people change their career from science to industry. I do remember the one which I like the most. A friend of mine, she said to me, she switched to some financial company, and she said to me, you should do that, come to us. I said, I don't want, I do want to stay in science. Now she said, you will feel like a Nobel Prize winner there because you'll be the smartest person in there. It was funny, but this is exactly, I think, what Dmitry was trying to say. When you are not anymore a scientist. When someone points a finger to you and says, you're not a scientist anymore, you can have a list of 700 publications. But as soon as you switch from academia or from fundamental research, you're not scientists anymore. I heard this myself addressed to me. And it's like, sure, you spend 20 years doing science, and then in 1 second, you become not a scientist anymore. And this hurts. And many people are really touched by that. And this is a huge problem. And I think if this is addressed, first of all, from our side, from scientific side, a little bit better, a little bit differently, it would help a lot. Because industry sometimes has open arms, right, ready to take us. But we, on our side, be afraid of critics from our colleagues, like, no, what they will say, right? What they will think about me. So this is a very good point. Amazing. Because this is exactly the problem we are facing. Happy to hear that not only we understand, that you do understand it on your side as well.
Yeah, today it's a super nice story that maybe it's the first time when I see that entrepreneur and people from industry and people from science, they have so common position in different questions. It's unbelievable, to be honest. But maybe it's just it's time. It's super. In the end, I want to say really thank you for your boss so that you find time for this discussion. I think that it's was super great and super productive. And to be honest, in the end, I see that we really have a lot of potential in cooperation between industry companies and scientists. But in the end, we have really so big gap and so many factors, different goals, finding IP, investors' opinions. It's for me, mindset, culture, and so on and so on. But communication, I hope that communication help us in this perspective, and we find new tools and new leaders with new culture and new opinion who can understand both sides, who can understand scientists, who can understand industry people. And in the end, in this way, we create new, bigger and better project and new products for our life in the end. Thank you, Irina. Thank you, Dmitry.
Thank you.
Yeah.
It was really nice to discuss that and to see that, yeah, we have many things in common, and we do face similar problems, and we both, like on both sides, we want to find this connection, communication, and communication. Again, we need to talk to each other more often. We need to organize events like this more often. We need to bring more people to talk about that, and then we find our next steps, what we can do in reality to progress, to develop it.
Yeah. And also thank you, our participant. I know that a lot of people watched in records after our webinars, and thank you for people who sent me by WhatsApp and Telegram different questions for you guys. It's super nice that we use not only Zoom communication, but direct communication. And I want to share one more again information about our website links. Please join us because we will have a lot of webinars on different topics. And for participants who was with us today in Zoom, we also have badge, electronic badge for participant, which add your professional development points for certification and others. Thank you one more again, Dmitry. Thank you, Irina, for this great discussion and a lot of really cool points.